All right, so we are going to be starting on applications of parametric equations. And so there's a few different things that you need to be aware of before we start off. We are going to be talking about, for example, initial velocity. And so I wanted my highlighter here. Initial velocity is going to be different than when I head down here and I say the parametric equations is like a different thing than initial velocity. So just as we're working through these, make sure you double check what the question is asking. So the initial horizontal and initial vertical velocity of any projectile with the magnitude v and direction theta can be found with the following equations. So this is what like initial velocity is what this means, is the magnitude times the cosine of theta. And then in the y direction, we have the magnitude times the sine of theta. So this is no different than what we've already done. Okay, so this is exactly the same where you take, 38 miles per hour times cosine of 7 to get the x, the initial horizontal and vertical velocities, okay? So then it says if a projectile is launched at an angle of theta, I think that's supposed to say angle, at an angle of theta with the horizontal, and the initial velocity and magnitude v, the path of the projectile may be described by the equations below. So this is where we're talking about giving parametric equations. And we also have to factor in gravity. So I'm going to use the letter G for gravity. If you've had physics, you might know this, that if we're working in meters, it's 32 meters per second squared. And if we're working in feet, it's 9.8 feet per second squared. And that's gravity. So parametric equations, remember, have an x and a y in terms of t for time. Okay. So I'm going to write two equations. In the x direction, I'm going to have t, my parameter t, times v cosine theta. Now, hopefully you remember that that's like time times the initial velocity. And then in the y direction, so x, remember, is our left and right. In the y direction, our up and down direction, this is where gravity is going to hit us. So we're going to have t times the initial velocity in the y direction. And then we're going to subtract 1/2 g t squared. Okay, so the only thing that you're going to fill in, we're going to fill this in, is when you're working here, are you working with feet or meters? And then you're going to fill in this thing that I gave you, that gravity is either 32 meters per second or 9.8 meters per second, depending on which one you're dealing with. So in my example, my little soccer ball kicking guy, it says find the initial. Okay, so I'm not looking for the parametric equations. All I want you to do is 33 feet per second with an angle of 29 degrees with the ground. So in the x direction, v is going to be 33 cosine 29. And in the y direction, it's going to be 33 sine 29. And then you're going to use your calculator to find these. So I do have Desmos up and running, and make sure that I'm in degree mode. So I want 33 cosine of 29 and 33 sine of 29. Oops. 29. So I got 28.9 and then 16.00. So 28.86, we'll go with that. So 28.86, and this is feet, not fleet, but feet per second. And for the y, we have like feet per second. Okay, so those you just type in Desmos. So here's where we get to the stuff where we start thinking about gravity. But if it just asks for the initial, it's kind of like the stuff we're doing. So I've got a whole bunch of stuff here about this Saints kicker, Tom Dempsey. But here's what's important. He kicks the football with the initial velocity of 94 feet per second at an angle of 68 degrees. So then it says provide tables. We're not going to provide tables. I can show you how to make tables on your calculator. I just don't usually use them. So it says find the initial velocity is where we're starting. So in our x direction, we're going to have 94 cosine of 68. And then in our y direction, we're going to have 94 sine 68. And when I did these, I'm not going to type them in Desmos right now, but I got 35.21 feet per second and then 87.16 feet per second. And then these will be important to remember because now we can use these in our part where we are going to use this with our gravity. So I think that's the end of my page here. Let me flip to the next page. So I'm going to write it down again up here just so that I have it. So I had Vx was 35.21 and my velocity in the y direction was 87.13. So then give the parametric equation. So that's when we're going to do this. X equals, and I need my parameter t times the initial velocity in the x direction. Okay, you could also write this as, so I know that bothers some people to have the t first. So you could always write x equals, oops, still have my eraser. X equals 35.21 t. Now in the y direction, this is where the gravity is going to take a hold of us. So I have y equals, I'm going to have my initial velocity times t minus, remember gravity in feet was 32, no, that was meters. Meters was 32 feet per second. Meters per second, do I have that right? Do I have them backwards? I think so, yeah. Gravity for, I can erase that, but instead, gravity for feet was 32 feet per second squared. Okay, that ran off my piece of paper here. So minus 1/2 times 32 t squared. And 1/2 times 32 is 16. So I am going to just write 16. Okay, so I'm going to erase this. So minus, my pen back, minus 16 t squared. So remember, this part was minus 1/2 32 t squared, and I wrote this as 16. So that's where the minus 16 t squares. And this is what happens. Gravity makes us fall, right? So now I have my parametric equations. Here's where you need either Desmos or your calculator, and you need to be thinking in terms of, is the question I'm asking you in terms of x or y? Okay, so I asked you a question. When the ball is 50 yards from Dempsey, what is its height? So I'm giving you the x direction because when he's kicked the ball, if it's 50 yards away, it's my little football guy, at 50 yards away, I want to know how high is it? Okay, so I know 50. Now the problem is that this is in yards. And I need feet because everything else is in feet. So yards, 1 yard is 3 feet. So 150 feet away is going to be the important piece here. I'm going to take my x equation. I know what x is, and I want to solve for my new parameter, t. So since I know 150, because that came from my thing here, I'm going to divide by 35.21 to find out what t is. Okay, so in Desmos, I'm going to take 150 divided by 35.21. So 150 divided by 35.21. And I got 4.26. And that's my time. I'm not done yet. So t equals 4.26 seconds. So the nice part about this is I now know that over the span of this here, From when he kicked the ball to when it reached 150 feet away from him, it was 4.26 seconds. Now I'm going to plug that into my y equation to see how high it was. What is its height? That's my y equation. So y equals 87.13. My t is 4.26. And then I minus 16, and I still have 4.26 squared. So as I type this into my calculator, so I'm going to go back to Desmos here. Hopefully I can do both of these things at the same time. I've got my equation was 87.16. Oh, there's no 87 there. 87.16. My t was 4.26 minus 16 t squared. Okay, so I got 80.9 feet. Okay, the height, I ran out of room, 80.9 feet high. So that's how high it is. When it's 150 feet away, it's 80.9 feet tall. It says when the height of the ball is 30 yards, again, we have to times 3. This is 90 feet. Okay, when the height of the ball, that's the y direction, is 90 feet, how far away is it from Dempsey? So I hope that you're thinking of this one more time. When the height, so he kicks the ball, and the ball goes something like this. So when the height is 90 feet, we should get 2 answers here. Okay, it probably hit 90 feet on its way up, kept going, and then when it fell back down due to gravity, it hit 90 again. This is my y answer, okay, because y is the height. So I need to say y, not y equals, but 90 equals my y equation, which was, I think I still have it up here, 87.13 minus 16, 87.13 t minus 16 t squared. Now there's a couple ways to do this, okay? One way would be the quadratic formula. It's an easy way. Some of you have that programmed into that. You would have to type it in as negative 16 t squared plus 87.13 t minus 90 equals 0. Then you could use the quadratic formula. So your a would be negative 16, and your b would be 87.13, and your c would be negative 90. Another way is going to be to graph this. And so I'm going to graph 2 things. I'm going to graph the equation. Now, Desmos doesn't do t, so I'm going to graph the equation y equals 87.13. I'm just going to use x minus 16x squared, and y equals 90. I'm going to graph both of those into Desmos and see what I get. Okay, so in Desmos, I've got 87. Look at, I wrote 15. 1316. What did we decide on? Like, you guys know me. 87.16 should have been that, and I put 5 earlier, but I think you guys still know what to do. All right, so 87.16, and then I can't use t, so I'm going to say x minus 16x squared. Now, I'm going to shrink this down. It should make sense that it's an upside down parabola, because even though my scale is pretty wonky here, I could go like 0 to, I don't need all of that. Just adjusting my scale here. Oh, there we go. Much better. So he kicks the ball, and then it goes up and comes back down. So the other one I need is 90, right? Y equals 90. And that should make a nice straight line all the way across. Oh, Desmos. Y. Oops. And that's only 6, and I need 16. Obviously having lots of troubles here. And then y equals 90. Okay, that made a straight line across. So just like I had said, when it should hit 90 twice. Now look at, there's 2 spots here. And if you remember right, I said we can't use t. So we used x instead of t. Our answers here are 1.37 and our 4.26 105. Those are my two answers for how much time. So there were two times, 1.37. And my other time was 4.11. That when I graphed this, that happened here, and that happened here. Okay, so I need to now plug these into my x equation to see how far away I was. So when you plug into your x equation, and I'm running out of room, I will tell you that my two answers for x were, and they could be different by rounding, and 143-ish were my two answers, and those were both feet. So hopefully you get something similar. Sorry, I didn't show that one, but I feel like I'm really running out of room. Hopefully you have enough room. So suppose he's making a 62-yard field goal attempt. I'm just going to write this now. This is 186 feet when you multiply it by 3. Okay, so he's making a 186-yard field goal attempt. 186 feet is our x direction. Okay, so we know the answer to our x direction. The top of the crossbar post is 10 feet above the ground. Will he be successful? Okay, so I've got, you guys are probably loving all my pictures. Here he kicks it. Okay, at 186 feet, will it be more than 10 feet or less than 10 feet? And that's what we need to decide. So I'm going to, since I know 186, I'm going to plug that into my x 35.21 t and find out how many seconds it is. So divide by 35.21, divide by 35.21. So 186 divided by 35.21. 86 divided by 35.21, and I got 5.28 seconds. Okay, so that's how long it's going to be in the air, 5.28 seconds before it is 186 feet away. Now I need to plug that in. I need to plug that into my y equation and determine, will it be taller than 10 feet? Okay, so my y equation, y equals 87.16 times my time minus 16 times my time squared. So you should be typing that in. Maybe hit pause because I'm not going to type it in. I got around 14 feet, which is greater than 10 feet. So yes, when it's 186 feet away, it will be more than 10 feet tall. Okay, then this is the last bit. After how many seconds does it reach its maximum height, and how far away from is Tom when the ball reaches its highest point? And then what is the maximum height of the ball? So I'm going to go back to my equation, or my Desmos here, and I'm glad I left it in here because I want you to be able to see how long this thing was in the air. Okay, so it was in the air for 5.45 seconds total. And so I always think, okay, so how far, like halfway through. So if I'm drawing this picture, I'm thinking 5.4, 5.5 is my total time here. That's why things are a little off. 87.16. You guys have done this whole video wondering why I didn't put a 1 there. It's okay. Now there's too many ones. So it didn't change too much, actually. Everything's about the same. So 5.4, it's exactly the same, in fact. 5.5 seconds it took. And so when does it reach its maximum height? About 2.7 seconds in. So when you're finding this here, you are thinking about your parabola. And 0, 0 is here. And 0, 5.5 is here, right? 5.5 comma 0. And halfway between that is 2.7 seconds. Okay, so after how many seconds does the ball reach its maximum height? You could find these two spots with the quadratic formula too. Okay, you would just set your y equation equal to 0 and solve using the quadratic formula. Some of you have that programmed into your calculator. Okay, so that's how you find zeros, and then just divide that in half. Then I want to know how far away is Tom from the ball. That is asking an x distance. So you're now going to plug in 2.7 to your x distance. Okay, so at 2.7 is your x distance. What do we have? 35.21 times 2.7 equals, how far away is he? So let's see, 35.21 times 2.7 seconds. That's so weird. 35.2, oh, that's why I'm 35.21 times 2.7 seconds. So 95 feet away, approximately. So 2.7 seconds is one answer. 95 feet away is the other answer. And what is the maximum height of the ball? Okay, if I plug in 2.7 into my y equation, because I want to know the maximum height, it's actually right on my graph here. 120 feet is my maximum height. Otherwise, you could just plug 2.7 back into your y equation. So what did I just say? Of course, I can't remember now. 120 feet is the max height. Okay, and those all just come off your graph. So if I was going to say like, there's more on, okay, I'm just going to write a note on here without doing these for you. You make two equations, x in terms of t and y in terms of t. And this will always have the minus 16t squared as long as you're working in feet. If you know x, plug in and solve for t. And then use that. If you know y, use the graph or quadratic formula to solve for t and plug in. So those are kind of like my short notes of what you do every time. Okay, you should be working on these as the week goes on. We're going to take a quiz next Tuesday, and it's only on this parametric stuff.